All right, 6.8 is a study on how to simplify complex numbers. We've been multiplying them in the last section. Here we're going to do some multiplying as well, but we're also going to do some adding and subtracting, which we haven't done yet. Now, when you add and subtract, it's really kind of easy because it's like combining like terms. For instance, look at number 3. You have 5 minus 7i. I do need to distribute that minus sign to the 8. Remember, you can also think of it as a negative 1 times the 8 is negative 8. And a minus a 2i, or a negative 1 times a 2i is a minus 2i. Now, all we got to do here is just combine the things that are alike. The numbers are alike. 5 minus 8, that's negative 3. And then we have minus 7i minus 2 more I. And you combine the i's just like they were variables, even though they're not. So minus 7i minus 2 more I would be minus 9i. And so we basically get minus 3 minus 9i. If you go down to number, let's look at number 11. We're going to be doing some distributing and multiplying, and so I'm just going to pick this one as an example. Do you see anything interesting about this example? Wait a minute, I copied the one below it. 3 plus 7i, 3 minus 7i. Let's just do, this is number 13. So we'll do 13 instead of 11. Do you notice anything about this one? It is in a difference of two squares pattern. And so we can multiply it all out, or we could say, oh, if this is like a is 3 and b is 7i, this is a plus b, a minus b. I could distribute it, or I could just work it really quickly by saying it's a squared minus b squared. Well, a squared would be 3 squared minus your b is 7i squared. That would be 9 minus, you have to square both the 7 and the I. 7 squared is 49, and I squared would be 9 minus 49, and then I squared is negative 1. So that's 9 plus 49 is 58. So we see that when we have a difference of two squares pattern, it gets rid of the i's. If you remember, when we were doing radicals, if we had this difference of two squares pattern, remember that's called a conjugate. It got rid of the radicals. So a difference of two square pattern not only gets rid of radicals, it also gets rid of imaginary numbers. And so we're going to be using that in this lesson. If you look at 27, we have another difference of two squares pattern. If you look at it, your A, let me kind of write in red, your A is like your square root of 2. Your B is like this negative square root of 5, and you've got a 1 plus and 1 minus. So if we write this as in a difference of two square pattern, that's going to be square root of 2 squared minus square root of negative 5 squared. I could FOIL all that out, but the chance of me messing it up is a lot more than if I just do it this way. So that's what we're going to do. The square root of 2 squared is 4, and then I have a subtraction sign, and then this is square root of 5, negative 5 squared, which, remember, that means there's two copies of these things. So let's simplify each one of them. Square root of negative 5, remember that each one of those is like saying that's the square root of negative 1 times 5. I'll just write it down twice. Well, each one of those square root of negative 1s is an I, and then I got a square root of 5. So I've got another I, square root of 5. So if I multiply these together, and again, I'm going slowly. Some of you may be able to speed through this a lot faster than what I'm doing. I times I is I squared, and square root of 5 times square root of 5 is just 5. Well, normally we would write that 4 minus 5i squared, but the only reason I'm not worrying about it is I squared is negative 1, and then I have a 5. So that's 4 minus negative 5, which is just 9 when you get done. So when we have that difference of two squares pattern, even if I have a square root of a negative number, I can get rid of it and end up with a positive value. Wait a second, what did I do here? I know what I did. Okay, so I messed this up, and you probably caught it. The square root of 2 squared is not 4. It's the square root of 4, which is 2, right? So if we go back and we fix all this, it would be 2 minus 5, which is 2 plus 5, which is 7. Okay, so I messed that up, but you can see how to fix it pretty easily. I wrote this down and did such a nice job explaining it, but I did not turn the recorder on. So let me kind of explain as we go. The original problem was this 2 over 3 minus I here, okay? Now, it's not legal to have 3 minus I in the denominator. Can't have i's, can't have radicals. So what we're going to do is use the conjugate of that. Do you remember how when we used the conjugate, when we had a radical, if I had like 3 minus square root of 2, I could multiply by 3 plus square root of 2, and it would get rid of the radical? Well, the same thing happens with these i's, and we actually saw it on some earlier problems on this video. So if I've got 3 minus I, and I want to get rid of the I in the denominator, I could multiply by this 3 plus I here. But if I do it to the denominator, I got to do it to the numerator up here. Now this is the pattern A minus B times A plus B, and that is equal to A squared minus B squared. So if A is 3, 3 squared would give me this 9 right here. And then it's minus B squared. Well, my B is this I, so that would be I squared. Well, let's just look at the denominator for a while. 9 minus I squared, that's the same thing. I squared is the same thing as this negative 1 here. So it becomes 9 minus minus 1, which is 10. Now all I have to do to finish this up is go do the numerator part. I had 2 here, and it got multiplied by this 3 plus I. So I've got to distribute. 2 times 3 is 6, and 2 plus I is 2I, and that's what I have written right here. And so we get this answer right here, but we realize we can reduce it because 6 and 2 and 10, they're all out. They're not under radicals. They're all outside, in other words. I don't even have any radicals here. But they're all divisible by 2. So I could just say 6 divided by 2 is 3, 2I divided by 2 is I, and 10 divided by 2 is 5, and get this answer that I had down here. But just to show you why that works, what you could do is say, well, 2 will divide out of those. So let's factor a 2 out of the top and a 2 out of the bottom, and so that's what I did. On the top, if I factor out a 2, 6 divided by 2 is 3, and I'll put my plus sign, and 2I divided by 2 is I. Now on the bottom, 10 is just 2 times 5, right? Okay, well then the 2's would cancel out, and that would leave you with this 3 plus I over 5. That's your answer. I wish I had not had to write over things to explain it, but I didn't realize I didn't turn the recorder on when I was doing it the first time. All right, 37 asks us to find the reciprocal of the complex number. Well, what's a reciprocal? It's when you take and you put 1 over that number. So we get 1 over 2 plus 3I. This problem ends up being like problem 31 that I just worked. That would be okay, except that we can't have I in the denominator. So how am I going to get rid of it? I'm going to create a difference of 2 squares pattern, and I do that by multiplying by the conjugate. And to get the conjugate, you write the 2 and the 3I, and since this one was a plus, this is a minus now. You just put the opposite sign between the two terms. This is like A plus B times A minus B, and that creates the perfect square pattern, A squared minus B squared, difference of 2 squares. So what I'm going to, if I do it to the bottom, by the way, I have to do it to the top, so let me go ahead and write it up there. Now on the numerator, 1 times 2 minus 3I is just 2 minus 3I. In the denominator, I have A squared minus B squared, where my A is a 2, so that's like 2 squared minus, and your B is 3I, so it's 3I squared. I'm just going to copy the numerator. 2 squared is 4 minus, now the 3I squared, I have to square the 3. 3 squared is 9, and I also have to square the I, so that becomes I squared. You have to square everything in a parentheses if there is a square on the outside. All right, so that becomes 2 minus 3I over 4 minus 9, but I squared is negative 1. Ah, the i's are gone finally, right? So I have 2 minus 3I on top, and on the bottom I have 4 minus 9 times negative 1. Now 9 times negative 1 is negative 9, so we get 4 minus minus 9, which is the same thing as 4 plus 9, and that becomes 13. Now your book goes ahead and it splits it up into 2 fractions. This is a perfectly fine answer, but your book says that's the same thing as 2 over 13 minus 3I over 13. I can put each piece of that over the 13. So this is what the book answer is going to look like. One that I assigned on this was 45. 45 wants us to show that 2 plus I is a solution to this equation, x squared minus 4x plus 5, and it basically wants me to substitute it in there. It wants me to evaluate the equation with that number or just substitute that number in. And what we want to see is this equal to 0? If it's a solution, it will be equal to 0. So let's put, everywhere we see an x, we're going to put a 2 plus I. 2 plus I, okay? Now 2 plus I squared, oh, that means I've got 2 copies of that. It's not 4 plus I squared, is it? It's a little bit more than that. So let's see, let me just do that piece of it. That's 2 times 2 is 4, 2 plus I is 2I, but then there's another I times 2, so there's a 2I plus a 2I, which is 4I, and I times I is I squared. All right, so that's, we'll take care of the I squared in a minute. Let's go ahead and look at the next thing. This negative, I've got a minus 4 times all that. Let's just distribute a negative 4. A negative 4 times 2 is a negative 8, and a negative 4 times a positive I is a negative 4I. So let me copy that down here. And then I got plus 5. And I'm trying to see, is this equal to 0? We don't know yet. The book's kind of told us it is, but we want to look at it ourselves. All right. Now, if you look at this, I've got a plus 4I and a minus 4I. So those are going to add up to 0. Now I have a 4 plus an I squared plus a 5. Okay, well, we know that 4 plus 5 is 9. And I squared is the same thing as negative 1. Okay, so it doesn't look like it's going to work, but I've made a mistake. So let's go find it. That's part of working things, is sometimes that happens. I had a 4 plus I squared. You know what I didn't do? I didn't copy down this minus 8 again. I just kind of left it out. So let me add it in here. That's going to make it work. I just forgot to copy it right here. So that's where I just forgot to copy it down, so I need to include it now. So let's go back and put it in. So 9 plus negative 1 is 8. Minus 8 is 0. Yes, 0 is equal to 0. It worked. So the moral of this story is when you plug stuff in, it gets to be kind of messy. Lots of stuff running around. If you forgot to write something down, it's really going to get you at the end. So, but the thing about it is the book pretty much told us that this was going to work, so we knew to kind of go back and say, okay, if it's not working out, I must have messed up somewhere. Go backtrack. And the place where I messed up was I forgot to copy this minus 8 from that step down to this step. And so once I did, in fact, put it in, it all worked out. So it's a solution because it turned out equal.